circuit analysis, resonance and coupled circuits. In this video, we are going to discuss about resonance and problem in RLC circuits. First of all, what is resonant? If you take the RLC series circuit, the resistor, inductor and capacitors are connected in series across the voltage source. At a particular frequency, consider for a particular frequency, our capacitive reactance and the inductive reactance are equal. Equal means the inductive reactance and capacitive reactance are opposite to each other. The same value but opposite to each other. So for a particular value, if both the particular frequency, if both values are equal, then they will cancel each other. The remaining element present in the circuit is purely resistive element only. For resistive element, the voltage and the current are in phase. The voltage and current are in phase. So that particular frequency is called as a resonant frequency, and the particular condition where the supply voltage and the current passing through the network are in phase means that phenomena is called as a resonant. Okay, the resonant means the network is in resonance when the supply voltage and current are in same phase or in phase. That phenomena is called as a resonance. The when will occur means when for a particular frequency the capacitive reactance and the inductive reactance are same, but they are in opposite direction, so they will cancel each other. The remaining element is purely resistive element. For a purely resistive element, the voltage and current are in phase. So the particular frequency, the resonance will occur. Right? The particular frequency is called as a resonant frequency. So the resonant means a network is in resonant when the supply voltage and current passing through the network or in phase is called as a resonant. So when will occur means a particular frequency when the inductive reactance is equal, opposite to the capacitive reactance, both they will cancel each other and the circuit may behave as a purely resistive circuit, and these conditions called as a resonance circuit, because for pure resistive circuit the current and the supply voltage are in phase, right? So in resonance circuit the current flow will be a maximum, right? At the resonant condition the series resonant inductance is equal to capacitive reactance. The frequency at which the resonance occurs is called as a resonance frequency. At resonance condition, both the reactive inductance and capacitance are equal, right? But they are in opposite directions. So they will cancel each other. So they will cancel each other, and the value will be 0. Okay. So for achieving this, the particular frequency, right, the resonant frequency, you can call as a resonant frequency. The resonant frequency is 1 by omega c. So omega c equal to omega c minus 1 by omega l equal to 0. So omega c equal to 1 by omega l. We can read it as omega c equal to 1 by omega c equal to 1 by omega l. So omega squared equal to 1 by LC. So omega equal to 1 by root LC. Okay. So the frequency is 1 by 2 by root LC. So omega equal to 2 by f. So f equal to 1 by 2 by LC. Right. So the frequency is called as a resonant frequency. This is the resonant frequency formula, right? So frequency f naught equal to 1 by 2 pi root of LC. This is the resonant frequency formula. Now we can discuss a problem how to solve the RLC series resonance circuits. We see the diagram figure, problem. A series RLC circuit with R value 50 ohms, L value 30 millihenry, and C value 40 microfarad has an applied voltage of 20 volt at resonant frequency. So resonant frequency means both are same value. Calculate resonant frequency and the current in the circuit at voltage across the element at resonance. So we have to find out voltage across inductor and voltage across capacitance, right? And find the quality factor and bandwidth. So we have to calculate three things. One is resonant frequency and the current in the circuit and voltage across the element at resonance. So for resonant frequency, already we know the formula 1 by 2 pi root of LC, right? So 1 by 2 pi root of LC, and for substituting the L value 30 into 3 power minus 3 10 power minus 3, and C value is 40 microfarad, 40 into 10 power minus 6. So substituting the value, we can get 145.362. So the resonant frequency formula is 1 by 2 pi root of LC. So next we calculated resonant frequency. Next is current. Current equal to V equal to IR, I equal to V by R. V value is given 200 volt. R value 50 volt is given. So 200 by 50, 4 amps. So the current value is 4 amps. Next one, voltage across the element. So voltage across inductor and capacitor we have to find out. So voltage across inductor VL, that is I into XL. I into XL, that is current into inductive reactance. Right? Current into inductive reactance. So the inductive reactance XL equal to 2 pi FL. So I into 2 pi FL. So I we calculated 4 amps, 2 pi we know. Frequency we calculated 145. Inductance is given 13. So by substituting all those calculated and given value, we can find out the VL. Like that, VC, voltage across capacitance. So VC equal to I into FC. FC means 1 by 2 pi FC. So I by 2 pi FC. So I value we calculated 4 amps. FC we calculated 145. That is resonant frequency. So 4 by 2 pi. Slide. So 1 by that is 4 by 2 pi f into C value. Right? So if we calculate it, we can calculate by substituting all those values, we can calculate the voltage across capacitance. Right? And next one is voltage across resistance VR. VR equal to I into R. I value 4 amps. R value given in the problem 50 ohms. So VR is 40 200 volt. And next they given they asked you to find out the quality factor. The quality factor formula is omega into L by R. So omega is 2 pi f. So 2 pi f L by R. 2 pi f is calculated, L given, R given. So if you substitute all those values, we can find out the Q value. All these values are known. By substituting all those values, we can find out the quality factor Q value. Next one, we have to find out bandwidth. So bandwidth formula is frequency resonant frequency divided by quality factor. So resonant frequency we calculated, quality factor also we calculated. That by substituting two value we can find out the bandwidth. So by this method we can able to solve the resonant.